One of the things that's important to understand about triangles is that there's what's called the triangle side length restriction, meaning that when you add together the lengths of any two sides of a triangle, that answer has to be greater than the third side. So, for example, if I drew this picture and told you this one was 3 and this one was 4 and this one was 10, you would have to know that's not possible because 3 plus 4 is less than 10. So in order for this side to be 10, these two sides have to add up to something bigger than 10. That's just something that you need to be aware of when we start talking about the law of cosines, to make sure that when you are finding side lengths that they actually work. We use pretty much these two congruence axioms for the law of cosines. Side angle side, side side side. With side angle side, we know that we were able to use that with the law of sines as well, but it does work with law of cosines. When you're dealing with side side side, that's when you're able to find missing angles using law of cosines. So this is the proof of the law of cosines. What we'll do is we will draw an oblique triangle with the vertex B on the origin. It's some distance A away because it's opposite angle A. Vertex C then has the coordinates A0. The reason it's A is because it's A units away on the x-axis and 0 units up. Vertex A has some xy coordinate. And what they've done is they've dropped this perpendicular line from vertex A, and it creates this nice little right triangle. So then what I can do is say, well, the sine of B being opposite over hypotenuse is y over c. And I can say the cosine of B being adjacent over hypotenuse is x over c. So in both of these instances, if I multiply by c on both sides, what I end up with is the fact that the x-coordinate really is equal to c times the cosine of b, and the y-coordinate is equal to c times the sine of b. That's how they came up with these values here. From this point, what we can do is say, well, if I know the coordinates of A and I know the coordinates of C, then I can find the distance from A to C, which is length B, by using the distance formula. So that gives me we've got x1 minus x2 squared plus y1 minus y2 squared. In order to get rid of the square root sign, I can square both sides of this, and that gives me b squared is equal to c cosine of b minus a quantity squared plus c sine of b quantity squared. The next thing that I will do is I will multiply this out, otherwise known as foiling. So b squared stays the same, but when I FOIL it, I get a squared, which is c squared cosine squared b, plus 2ab So that would be, in this case, it'll be minus because this second term here is being subtracted. So it'll be minus 2ac cosine of b, and then I have plus b squared. And that's all being added still to this whole thing squared. So I'll have to drop that down below. So that'll be c squared sine squared b. The next thing that I will do is regroup. So I've got b squared still, and I will put c squared cosine squared b plus c squared sine squared b minus 2ac cosine b plus a squared. From here, I'm going to factor the c squared out of this. At the same time, I'm going to move this plus a squared way to the front. So this gives me b squared is equal to a squared plus c squared times cosine squared of b plus sine squared of b minus 2ac cosine of b. From here, I need to remember my Pythagorean identity, that the cosine squared plus the sine squared is equal to 1. So really, this whole thing is equal to 1, and 1 times c squared is just c squared. So as I simplify, finally, I get b squared is equal to a squared plus c squared minus 2ac cosine of b. And this is one form of the law of cosines. If I had put angle C at the origin, then the distance I'm finding would be C, and the formula would look a little different. The same if I had put angle A at the origin. So this is what the law of cosines looks like. This is the one we actually solved. Here are the other two forms. Please notice, you've got side A, side B, side C. All of them are there. Side A is on one side of the equal sign. On the other side, you don't have side A at all, but you do have angle A. Again, side B is on the left. On the right, we don't have lowercase b anywhere, but we have capital B, angle B. Same thing with the third form. On the left, we have side C, no lowercase c anywhere on the right, but we have angle C. So that's a really good way to memorize it. If you take a note here, it says that if angle C is 90 degrees, so they're talking about this particular one, well, cosine of 90 is 0, so that makes this whole thing equal to 0, and you end up with Pythagorean theorem. Does that mean that you are allowed to use Pythagorean theorem in this class? No, it does not. You are still not allowed to use Pythagorean theorem, but this is one of those things that proves why the Pythagorean theorem works. So let's do a problem. We're going to solve triangle ABC. And we are going to use the law of cosines to start this problem. What I notice is that I have angle B, but not side B. So I can solve for side B. So that'll be b squared is equal to a squared plus c squared minus 2ac cosine of b. side B is 47.202. From here, I can just simply use the law of sines to find the other two sides. So I could say, and I'm sorry, I meant the other two angles. So we would do the sine of B over 47.202 is equal to the sine of A over 28.2. I have angle A as 34.947. And then to find angle C, I just do the angle sum theorem. So 180 minus 73.5 minus 34.947, which gives me 71.553 degrees, and that's angle C. We'll try another one. This one is a side-side-side triangle. Now, the one thing that I want to emphasize to you is that when you are given a side-side-side triangle, I want you to always start by finding the largest angle. The reason is because we use law of cosines for pretty much the first step, and then we use law of sines for the remaining steps. When you take the inverse sine of a particular ratio, it will not give you an obtuse angle. It will only give you acute angles, whereas the law of cosines will give you an obtuse angle. So you're going to find the largest angle first. It may or may not be obtuse, but once you have done that, you find the two smaller angles. The reason that I circled this C is because it's the largest side, which means angle C will be the largest angle. So I will start with C squared is equal to A squared plus B squared minus 2 times A times B cosine of C. Oops, I hate it when that happens. I get angle C as 118.560 degrees. I will tell you what I put into my calculator. 59.3 squared minus 25.4 squared minus 42.8 squared. Then I divided by negative 2 times 25.4 times 42.8. Once I hit enter, I got a decimal, and I took the inverse cosine of that decimal in order to get this value. Once I have angle C, I can use law of sines to find angles A and B. So, sine of C over C is equal to the sine of A over A. This gives me a value for angle A of 22.1 degrees. And then when I solve for B, I will get approximately 39.3 degrees. So, two boats are leaving the harbor at the same time. They are traveling on courses that make an angle of 82 degrees 20 minutes between them. When the slower boat has traveled 62.5 kilometers, the faster one has traveled 79.4 kilometers. At that time, what is the distance between the boats? So, to get started, the boats are at the same location. One of them travels in this direction. What I'm putting in my calculator is this whole thing all at once. And when I get that answer, which is going to be a huge number, I then take the square root of both sides. So I will then take the square root of my answer, and I get this distance to be 94.268. Being it's a word problem, I can say the distance between the boats is 94.268 kilometers. Here we're being shown a roof truss and asked specifically for angle C, because we are not asked to find every single angle measure. We don't have to find the largest angle first. Here, all we're looking for is angle C. So I start with C squared, because that's what I'm going to need the cosine of. So you start with the side opposite that. 9 squared is equal to 6 squared plus 11 squared minus 2 times 6 times 11 cosine of C. What I put into my calculator: 9 squared minus 6 squared minus 11 squared, all divided by this, so this is in parentheses, negative 2 times 6 times 11, and then I close my big parentheses and hit equal. That's going to give me the cosine. Once I get that decimal for cosine, I do inverse cosine of that answer, and I find that angle C is equal to 54.574 degrees. To review what we have worked on, we had 4 possible cases of oblique triangles. The first case is one where we know 2 angles. And the truth is, once you know 2 angles, you know the third angle. You also have to be given one side in this case. So what you do is you find that third angle, and then you use straight up law of sines for everything. So if you have all the angles, one side, law of sines. Case 2 was our ambiguous case. We had to find one of our missing angles using law of sines. Then we had to use the angle sum formula to find the remaining angle. We had to find that last side. Then, big piece of information here, you had to repeat those steps in order to find whether or not a second triangle existed. Today, we looked at instances where there are 2 additional cases. Here, you know 2 sides and one of the angles. So the first thing you'll do is find that third side. You'll find the smaller of the 2 remaining angles using law of sines, because remember that law of sines will only give you acute angles. So you want to make sure that you're finding the very smallest of the angles, because it will be acute. Then you find the larger of the 2 using the angle sum formula. The last one is when you have 3 sides. Here you find the largest angle using law of cosines. Once you have the largest angle, if it is not an obtuse angle, then you have an acute triangle. If it is an obtuse angle, the other angles have to be acute anyway. So it doesn't matter if you're using law of sines, but you will always find the largest angle first. Here with side angle side, of the 2 angles that remain, you'll find the smallest one first, because you're using law of sines. So you can think of it this way: law of sines, small angle. Look at these problems, they're on your sheet, and just jot down really quickly next to them how you would go about solving these. So pretty much, would you use law of cosines first, or would you use law of sines first? You don't have to actually solve them, but think about what method you would take.